Okay, so finally, let's finish up by graphing a couple of functions and their inverses and seeing how they're reflections over the line y equals x. So first off, we'll start with just a linear one, f of x equals 2x plus 1. Very quickly, let's find the inverse, y equals 2x plus 1. We'll switch x and y, so x equals 2y plus 1. We'll subtract 1 on both sides, so x minus 1 equals 2y. We'll divide by 2 on both sides, so y equals x minus 1 over 2. Y equals x minus 1 over 2. Now, when we write that, let's go ahead and write this as 1 half x, f inverse, 1 half x minus 1 half. So that we can kind of see it in the slope-intercept form a little bit easier. So just giving a 1 over 2 here, negative 1 over 2 here, same thing. Let's go ahead and graph the original first. So this is mx plus b, so we begin with the y-intercept, that's a 1. We're going to rise to run 1. So up to right 1, up to right 1, up to right 1, up to right 1, down to left 1, down to left 1, etc. Let's go ahead and draw that. That's our original. And our inverse, so we begin with this negative 1 half, so we begin here, negative 1 half, and we're going to rise 1, run 2. So we're going to go up 1, right 2, up 1, right 2. We can also go down 1, left 2. And if we draw our inverse, free ad for Panera Bread there, we can see that these guys are crossing at the line y equals x. Remember, y equals x is just the line that goes straight diagonal through like 1, 1, 2, 2. Pen. Right, that's the line y equals x. Everything is just a reflection. Oops, I guess it should be this way. Reflection over this line. And you could test some points and you could see that there's just straight up reflections. So for example, this line, this point right here is 0, 1. He's going to go over here and be reflected to 1, 0. So everything just switches. Let's try one more. So this is an example we did earlier. F of x equals the square root of x plus 4. And remember our domain, this has got to be 0 or greater. So x has to be, if you set this greater than or equal to 0, we get x must be greater than or equal to negative 4. And our range, we saw that y is greater than or equal to 0. So if we graph this, the domain says x must be greater than or equal to negative 4. So our x is going to start at negative 4. 1, 2, 3, all the way over here. And how do we graph this? Let's just go ahead and do a t-chart since we don't know too much about how to graph these square root functions yet. So we know that negative 4 is going to go to 0. Let's try negative 3. Negative 3. If x is negative 3 plus 4 is 1. Square root of 1 is 1. So negative 3 goes to 1. Let's see, what would give us a nice even one here? For example, if I was able to get the square root of 4, that would be nice. So let's say we have 0. If x is 0, we're going to get 4. Square root of 4 is going to give us 2. So 0 is going to go to 2. So something like that. It's going to curve up like this. Arrow. Now let's go ahead and take a look at the inverse function. We found this earlier. This was our inverse. Remember though, the domain is going to be x is greater than or equal to 0. That comes from here. And the range is going to be y is greater than or equal to negative 4. Okay, so what is different about this? Let me go ahead and draw a normal parabola. So negative 4, so I shift down 1, 2, 3, 4. And if I did a little t-chart for this guy, let's say I plugged in x is 1. Well, I could either do it like this, plug in a 1 here, I get 1 minus 4 is negative 3, or I could just look over here and just switch these. So 1 goes to negative 3, 1 goes to negative 3. Oh, I could use this then, I guess. 2 is going to go to 0, and so on and so forth. Now, normally when I draw a parabola, so I would have it go like this, 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 and this. But look, we've already restricted our domain. Our domain says x must be greater than or equal to 0. So we cannot actually do, if we drew this in like this, da, 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 if you drew in this part of the parabola, you're actually going to have to delete it because our domain, x must be greater than or equal to 0. Remember, we could not have, it's got to be a complete just reflection, so we're not going to actually have this part of the parabola showing. So just this part is what you're going to graph. And if we look, I'll use the orange. Again, the original function and its inverse are reflections across this line right here, this line y equals x. Everything is a reflection. So for example, we've got 0, 2 here is going to 2, 0 here. Over here we've got negative 1, 2, 3. Negative 3 goes to 1. And over here we've got 1 goes to negative 3. So everything is just switched.